Good morning to all my YouTube viewers. In this video, I like to discuss about test paper 3 is remaining question. It will start from question number 18. Let us start the paper. Two radioactive nuclei P and Q in a given sample decay into a stable nucleus R. At time t equal to 0, number of P species are 4 n naught and that of Q are n naught. Half life of P for conversion to R is 1 minute, whereas that of Q is 2 minutes. Initially, there are no nuclei of R present in the sample. When number of nuclei of P and Q are equal, the number of nuclei of R present in the sample would be. Here, two radioactive substance is given, that is P and Q. Initial amount is 4 n naught and n naught, and half life for P is 1 minute, whereas for Q it is 2 minutes. Now, this it will convert to stable nucleus R. Now here condition is given when number of nuclei of P and Q are equal, that should be the timing for decay. Let us see how we can solve this problem. Say after time t, initial sample of P is 4 n naught and initial sample of Q is n naught. Half life for first one is 1 minute, for P it is 1 minute, and for Q it is 2 minutes. Now after time t, both P and Q will be equal. After time t, both P and Q will be equal. So after time t, P species will left this one, that means 4 n naught 2 to the power half number of half times, that is t divided by 1 minute, number of half time for P sample. Now for Q sample will be n naught divided by 2 to the power t by 2 minutes, because half life is here 2 minutes for sample Q. Now from this relation we can, this will be equal in amount, that is the condition given here. Now we can solve this, and from this equation we can get time will be 4 minutes. That means for the sample P it will have 4 half life, number of half life will be 4, because each half life will take a time 1 minute, so time t is the 4 minute here, so number of half life will be 4, and for Q sample number of half life will be 2. Now then how much will remain from decay? That means this the amount will left, that is n naught by 4. I mean 4 n naught is the initial divided by 2 to the power number of half lives will give you n naught by 4. Similarly for Q sample it will be n naught by 4 will come because number of half lives will be 2 here. If we substitute, this will give us n naught by 4. NQ will give n naught by 4. You can see here. Substitute here 4, that means 2 to the power 4, that means n naught by 4 will come. that is this one, n naught by 4. Now, therefore, after conversion to stable nuclei R, that will be how much converted? That means 4 n naught minus n naught by 4 for P element. This is for P element, and for Q species it will be n naught minus n naught by 4. Sum of these two will give total transformed, that is 9 by 2 n naught. That will be the total conversion taken place. Now, job number 19. Two pendulums differ in length by 22 centimeter. They oscillate at the same place so that one of them makes 30 oscillations and the other makes 36 oscillations during the same time. The length in centimeter of the pendulums are, we have to find out, we require to find length of the pendulums for each case. Now, to do this, let us start by, we know the time period is 2 pi root under L by G, there is a basic formula, and say L2 is, because number of oscillations more in case of second one, that means 36 is the number and another is 30 oscillations. That means time period for 36 oscillations will be 36 oscillations are taking place in a definite time, let's say t. That means 36 divided by t will be 2 pi root under L2 by G. Now, for 30 oscillations, it will be 30 by t equal to 2 pi root under L1 by G. L2 will be greater because time period is more here. Now, from these two equations and from the first equation, that is L2 minus L1 is 22, we can sort out, we can solve. Just dividing these two, we can get 5 by 6, that is equal to root under L1 by L2 will come, squaring, we can get this one 25 by 36 L1 by L2. Now, we have to simplify between first one. Already have seen that first one L2 minus L1 is 22. From here substitute in this equation, that is L2 minus 22 will come L2 minus 20 instead of L1. Substitute here and then find out in terms of L2 equation, that will give you L2 will be 72 centimeter. And substitute in the first equation, you will get L1, that is 50 centimeter. That means our as per question 72 and 50, that is first choice, this will be the answer. This is a simple job. Now, come to next job. A block released from rest from the top of a smooth inclined plane of angle theta 1 reaches the bottom in time t1, and the same block released from rest from the top of another smooth inclined plane angle theta 2 reaches the bottom in time t2. If the two inclined planes have the same height, the relation between t1 and t2 is, and the most important point, all the contact surfaces of the plane is smooth. That inclined surfaces is smooth, and the block surface is also smooth, and the inclined plane is placed on the ground, that is not smooth. That means inclined plane is rest, and inclined plane height is fixed. Only thing, gradients are different. Now for first situation, when angle is theta 1, it has taken time t1, and second situation the angle is theta 2 and it is time taken will be t2 here. We have to find out relation between t1 and t2. Very simple job. Now you see this diagram, you can see theta 1 and theta 2 height is same, placed on a rough surface, horizontal surface, and inclined portion is perfectly smooth. Under that situation, we know that distance travel along the incline, say height is same, so if you take this length is say s1, s1 sin theta 2 will give height. Trigonometrically we can find out, that means h by sin theta 1, h by sin theta 1 for this triangle smaller will give this distance travel, this path, h by sin theta 1. Similarly for the other one it will be h by sin theta 2 will give this length, and this length means distance travel by the object, that is along this direction acceleration is g sin theta, as you know. So in first situation h by sin theta 1 will be equal to half g theta 1 half g g sin theta 1, that is the acceleration along the incline, into t1 square. Similarly the other equation will come half g sin theta 2 into t2 square. Just make a ratio of these two, h will get cancelled. You will see here is sin theta square will come and denominator will be sin theta 2 sin square theta 2 will come. Now take the root of this and ultimately t1 by t2 will give us sin theta 2 by sin theta 1. Just reciprocal relation will come. Sin t1 by t2 will be sin theta 2 divided by sin theta 1. That is answer C is the choice here. You can see. See t2 by t1 sin reciprocal relations. You can see here. Now come to next job. A metal cylinder of length L is subjected to a uniform compressive force F as shown in the figure. The material of the cylinder has Young modulus Y and Poisson's ratio is small sigma. The change in volume of the cylinder is, we have to see delta V. Uniform, most important point, uniform compressive force F is given here on the cylinder. Now as we know, Young modulus equal to stress by strain, longitudinal stress by longitudinal strain. Here instead of sigma we can write force per unit area, instead of epsilon we can write delta L divided by L, strain, and just a capital L will come in the numerator. Then that means y equal to, this is the relation, and we know fundamental definition of sigma, I mean Poisson's ratio, will be lateral strain over longitudinal strain, and minus sign is always there. If length increases, diameter or radius will decrease, or if it in this case this is positive because compression taking place, so diameter will increase, radius will increase, but length will decrease. Any one of them increases mean other one will decrease. Suppose this is increasing, so this will decrease, so ultimately minus will be there. Minus is a common thing here. Now as we know, volume can be written pi r square into L. Differentiate this, you will get pi, differentiating r square means 2r dr, and L will remain constant, plus r square and pi constant, pi is already taken out, r square into dl. Dividing by the volume you will get dv by v, like this type of expression will come, and you just divide with respect to this one divided by this, plus this one divided by the two parts. That means dl by L will come, plus 2 into dr by r will come, delta r by r will come. Now from here delta r by r can be replaced by sigma into this one, minus sign is also there. So you can substitute here longitudinal strain, that will give us, if we substitute this minus will come, and sigma delta L by L, sigma delta L by L, take out delta L by L, you will get 1 minus 2 sigma. Already 2 is here, you can see the 2 sigma will come, 1 minus 2 sigma will come. Now from delta L by L, we can substitute from the first equation delta L by L, you can substitute force divided by Young modulus into area, force divided by Young modulus into area within bracket 1 minus 2 sigma. We require to find out only delta V. In left side delta V by V is there, multiplied by V. V means area into length of the cylinder. So area will cancel, FL divided by Young modulus will remain within bracket 1 minus 2 sigma. That will be the answer for this. Now job number 22. Two persons A and B are located in XY plane at the points 0, 0 and 0, 10 respectively. Coordinates are given. The distances are measured in MK system unit. At a time t equal to 0, they start moving simultaneously with the velocities v suffix a equal to 2j meter per second and vb equal to 2I meter per second respectively. The time after which A and B are at their closest distance is, that means at location 0, 0, A is there, A is present, person A is present, and at 0, 10 position person B is present, and both will start at same time. A will start moving towards y-axis, straight y-axis 2j meter per second. After time t it will be 2t, and definitely other one is going along x-axis, so it will be twice t along x-axis will be the distance travel. Now let us see how we can solve this job. Here you can see A is present here, B is present here, 0, 10. And they will start together simultaneously at the same time. So after time t, A say it is somewhere at this position, that is A dash, and B will travel say at a distance twice t, that is B dash. This is their present position. A is here, B is here. Distance between them is this one. So this initial distance was 10 minus this distance travel. That means 10 minus twice t will be the present distance. And here time is distance is twice t. I mean x is the distance. Then what will be the distance between them? True distance between them will be this distance, A dash B dash. So to find out A dash B dash, say it is S, we can write like this: S square equal to right angle triangle. S square means twice t square, x square means twice t square, and this distance base of this right angle triangle. Base is 10 minus twice t. Base is 10 minus twice t whole square. Simplifying this one, you will get expression like this: S square equal to, you will get this type of expression: x square equal to 8t square minus 40t plus 100. You just can break this one mentally, you can do this. You can see 4t square will come, another 4t square will come here, 8t square. Similarly minus twice a, that will give you 40 minus 40t plus 100. This is the simple thing. Then we have to use differentiation. We have to do differentiation to get least distance between these two. There will be a situation when at a particular time the distance between a dash b dash will be minimum. That means differentiating this one twice as ds by dt, twice as ds by dt will be equal to 0, ds by dt will be equal to 0 to get that minimum distance. That means differentiation of this one means 16t minus 40 equal to 0. That means t will come 40 by 16, 40 by 16 second, that means 2.5 second. Later you will get this situation. Our answer will be this one only. (2.5 seconds). A is the choice here. Now come to a next job, that is a current carrying wire is given. We have to find out magnetic field at the center O, and small portion is in a straight line form. The pattern which is given shown here, this is a straight line form, other part is. Now this angle is twice theta, you can see. Now what will be the remaining angle? Remaining circular part we have to find out. Circular part will be 2 pi is the total circular part, minus 2 theta will be the angle subtended in the other side of the triangle. I mean here 2 pi minus 2 theta. With respect to 2 pi, that part will be available. That means 2 pi minus 2 theta divided by 2 pi will be the part of the curve part. That is curve part portion. And this straight line portion, already it is understood that this distance, say radius is r given here, this will be how much? R sin theta. R sin theta, r cos theta will be the perpendicular distance, r cos theta. If you take a perpendicular from here, this is r, this angle is theta, so r cos theta will be the perpendicular distance. For this straight wire, we know formula, that is mu naught I by 4 pi r, perpendicular distance within bracket sin alpha plus sin beta, that is known to us, is it not? Using this, simply we can get it. For the straight portion, PS or this one SP will be how much? Mu naught I 4 pi r, perpendicular distance is r cos theta, already it is told that this angle is theta, each one is theta, so this distance will become r cos theta. The perpendicular distance, bracket sin alpha means here theta, again sin beta means theta, so it will give you twice sin theta, that means mu naught I by 4 pi r tan theta. बाद में here we have done. Anyhow, same here we have done. Now we will get this expression, I naught mu naught I tan theta divided by 2 pi r will come. You simplify from here, you will get sin theta by cos theta, and the 2 will cancel from here, 2 will come, 4 2 pi r will be there in the denominator. Mu naught I tan theta by 2 pi r you got for the straight wire. Then curved portion is left, curved portion part is known, that is this part. PQS is the curved part, curve shown in this symbol in this way, and that is this is a part of the circle, that is 2 pi minus 2 theta by 2 pi. That part, how much for circle? Mu naught I by twice r only, you know this formula. And from here we can solve, simplify, just take out mu naught I by twice r is common, mu naught I by twice r is common, pi is not taken, mu naught I by twice r. Then tan theta by pi will left here, tan theta by pi will left here, and here also this part gone, this only portion is left here, this one. Simplifying between these two, just you can see 2 will cancel if you take out 2, numerator denominator will cancel, then you simply tan theta plus pi minus theta will come here, and outside mu naught I by 2 pi r. That will be the final expression for this problem. Then which one is answer? You can check. I think this one will be the answer, D. Yes, D is matching. D is the answer. Now come to next job 24. Density of ocean water varies with depth. This is due to elasticity, surface tension, viscosity, all of these. Which one is right? It is because of elasticity of the medium. Number A is the correct choice. Elasticity of water between the water molecules will be responsible for this. Next job is this one, 25th. An object moving with a speed 6.25 meter per second is decelerates at a rate given by, this is the expression given, where v is the instantaneous speed, the time taken by the object to come to rest. Ultimately you have to go for rest. Now dv by dt is given, just rearrange and you will get this type of expression, that is root under v is there, you can see. Now this type of expression will come, that is integration dv by root under v, and the right side minus 2.5 dt, integration 0 to t, and this will be 0 to v to 0, because finally it has to reach to 0 velocity, rest. So v to 0 is the limit. After integration you will get this v to the power minus of plus 1 divided by minus of plus 1, v to 0 and right side 0 to t. So this limit we have to take care properly, otherwise mistake will be there. That means it will give us 2 into v to the power half equal to plus 2.5 into t. Squaring we can get 4v equal to 6.25 t square. Substituting t, we can solve for t by substituting v. V is given here. V is 6.25 given in the question, you can see. In the question it is given 6.25 meter per second. So substitute this, and then 2 seconds is required to stop the motion to 0 level. That will be the answer for this. Now next job 26. The magnetic flux phi through a stationary loop of wire having a resistance capital R varies with time as phi equal to a t square plus bt, where a and b are positive constant. The average EMF and the total charge flowing in the loop in the time interval t equal to 0 to t equal to tau respectively are. What it means? Flux is given, flux phi is given at a particular instant, that is a t square plus bt. A, b are both are positive constant, and you will go for 0 time t equal to 0 to time t equal to, and we have to calculate average EMF and charge flowing. Average EMF and charge flowing. So we can do in this way. Change in flux delta phi. Phi is given, delta phi will be, because time is variable, so we will get a time final minus time initial whole square plus b, as this equation has given, time final minus time initial. And we know time final means tau started with 0 time, this will be the expression, very simple, tau minus 0, then you will get delta phi equal to a t square plus b t, b tau. A tau square plus b tau, that will be delta phi. And we know charge flow means delta q equal to delta phi by r. Delta phi by r is the amount of charge flowing. We can very easily you can derive this, because EMF we know d phi by dt, and EMF means I into r, and I means delta q by delta t, and the delta t remove and delta q will come delta phi by delta r. Delta phi by r will come for delta q. So substitute delta phi as it is available here divided by r. This will be the one of the relation among the answer. Now charge flowing in the loop will be this one. Now average EMF, that is a standard equation, integration of EMF into dt, integration of EMF dt divided by integration of dt for a specified time, that is 0 to tau, 0 to tau. This is EMF d phi by dt. Now this is the way we have to calculate average for any variable items. Now here d phi by dt is how much? Differentiate this original equation. D phi by dt will be twice at plus b, twice at plus b into dt, that you have to integrate, then divided by dt 0 to tau integration. After integration and substituting tau, limit, we will get a tau square plus b tau will come divided by tau in the denominator. Taking out tau common here, from here we will get average EMF will be a tau plus b. So our answer will be, charge will be a tau square plus bt by r, and for EMF, average EMF will be a tau plus b. That will be answer. Here answer is A, I think A. Huh? You can see a tau plus b for the average EMF. First one is EMF, then charge is this one. Already have shown. So A is the answer. Now job number 27. Two identical capacitors 1 and 2 are connected in series to a battery as shown in the figure. Capacitor 2 contains a dielectric slab of dielectric constant K as shown in the figure. Q1 and Q2 are the charges stored in the capacitors. Now the dielectric slab is removed and the corresponding charges Q1 dash and Q2 dash. Then there are four relations, we have to see the correct one. Now as it is in series connection, so it is understood that both the capacitor can hold equal amount of charge only. Now as we understand, this is the basic thing required. The capacitor which is just it is, don't have any dielectric, that its capacitance will be epsilon naught A by D, and for the dielectric it will be epsilon naught K A by D. Okay. Now when they are connected in series, so definitely charges will be same. That is the basic requirement here. Capacitors are in series connection, those charge will same for both the capacitors Q1 and Q2. So potential drop will be V1 plus V2 equal to V, because drop here, and that will be sum up to this supply voltage, that is V. Instead of V1 we can write Q1 by C1, and instead of V2 we can write Q2 by C2, and Q1 and Q2 both are equal. Take instead of Q2 you can write Q1, take out Q1 and you will get an expression, this V is C1 C2 divided by C1 plus C2, and substituting C1 and C2, that is known to us, this one and this one, substitute here, ultimately you will get an expression Q1 equal to Q2 equal to V epsilon naught capital A divided by D within bracket K divided by 1 plus K. That is the point. Q1 is how much? V epsilon naught capital A divided by small d within bracket capital K divided by 1 plus cap K. That is the relation will come when dielectric is present in the present here. When dielectric is removed, again relation will be same type, that is Q1 dash equal to Q2 dash will be there. Charges will remain same because they are in parallel. So total capacitance will become in series, means C half of the capacitance, that is Q1 dash divided by capacitance, that means C by 2, and if we simplify, it will give Q1 dash 2 by C equal to V, potential drop of the total drop across the capacitor. Then that means from here Q1 dash equal to Q2 dash equal to, you can write V into C by 2, this will come. That means C, for C we know epsilon naught A by D, that means V epsilon naught A by twice D will come for this relation. Now from here Q1 dash over Q1, if we take this ratio of this one, this one divided by here, that is q1, this one, these two ratio, then we will get this type of relation, half 1 plus k by k. And if you take q2 dash by q2, in that case it will come 1 plus k by twice k, and this choice is given in the question, so this will be the answer, k plus 1 divided by twice k. C will be the choice here, others are not matching, so this is only matching, so one answer is correct here, so this will come. Now next job is, electromagnets are made of soft iron because of soft iron has low retentivity and high coercive force. Number B, high retentivity and high coercive force. Number C, low retentivity and low coercive force. Number D, high retentivity and low coercive force. Which one is correct? We have to see the property of soft iron. Now, for soft iron, this is called hysteresis curve, that you know, and this is for iron and this is for steel. For iron, what you see, this is called retentivity, and this is called coercivity. This length is called coercivity and this height is called retentivity of the magnet. Now, for iron it is found the retentivity is high and coercivity is less than steel, and you can see the area which takes this hysteresis curve, area here is much less than the area what it has occupied here. That means hysteresis loss for iron will be much less than steel. Now, these are the things to be known very correctly, that iron has high retentivity you can see iron has high retentivity and low coercivity with respect to steel. Iron has high retentivity and low coercivity with respect to steel, and so for electromagnet iron is better than steel. Now more points, area of the hysteresis curve for iron is smaller than steel. That means hysteresis loss for iron is less than steel. Now this property is being clearly specified in number D, high retentivity and low coercive force, and this should be the choice, D should be the choice, but in the answer script it has given that C is answer. C cannot be the answer, D will be the answer. If you have this question paper with you, you can check that in the answer script it has given low retentivity and low coercivity force. That is not correct. Here D should be the correct answer, mind it, D should be the correct answer, because iron has both the properties, high retentivity and low coercive force. That means its hysteresis curve will be much less than the hysteresis curve for steel. So the iron is preferred over steel. Now come to next job, 29. A screw gauge gives the following reading when used to measure the diameter of a wire. Main scale reading is 0 millimeter, circular scale reading is 52 divisions, and 1 millimeter on main scale corresponding to 100 divisions of the circular scale. That means their main scale has no divisions here, zero division. Definitely measurement will be below 1 millimeter. That is the first thing you have to catch. Now 52 divisions equivalent to how much millimeter? 100 division equal to 1 millimeter, 1 division equal to this much. 52 will be unitary method also you can use, and you will get 0.52 millimeter in this measurement. And means 52 will 0.52 millimeter, which is equal to 0.052 centimeter. That is answer. Answer A is correct here. Now come to job number 30. Here, when a metal surface is illuminated with a light of wavelength lambda, the stopping potential is V0. When the same surface is illuminated with a light of wavelength twice lambda, the stopping potential is V0 by 4. If the velocity of light in air is c, the threshold frequency of photoelectric emission is. Now, as we understand that work function for a metal is fixed. Now, according to incident light, a stopping potential will be decided, stopping potential will be measured. Now, here when wavelength lambda is incident on it, its stopping potential is V0. When wavelength is twice lambda, its stopping potential decreases to V0 by 4. That means we will get two equations from these two conditions. Let us start. Now, stopping potential is V0 E will be the total amount of energy, maximum kinetic energy, that is V0 E will be h nu minus h nu naught. That is threshold frequency. This one we like to measure nu naught. Now from here we can write the incident light has got the wavelength lambda. So c by lambda will come instead of nu, c by lambda. This is first equation. Now when the incident light wavelength decreases to twice lambda, I mean this one, c by twice lambda, then this part is fixed for a particular metal, work function is fixed. This is going to change. V0 by 4 will be the present stopping potential into E. Simplify this, we will get V0 E, this 4 multiply this side, you will get 2h c by lambda and 4h nu naught will come. Solving between these two equations, substitute this one here and we can get remove this one V0 E from both the equations. Everything will come in terms of c and h and nu, all these things, lambda. So simplify from these two, you can get you will get this one h c by lambda minus h nu naught, which will be twice h c by lambda minus h 4 times h nu naught. We have to find out nu naught. Make this one as a subject, bring left side, thrice h nu naught will be, bring this one right side, you will get h c by lambda. So that means nu naught will be c by thrice lambda. That is the minimum frequency required, the threshold frequency to get the metal activated for photoelectric effect. Thank you very much. Hope that you are gaining and support us. You subscribe to other people so that other people must get the benefit of it, and also like so that we can give our best effort to improve your performance. Helping each other will help. Only you must help others so that you will be benefited by somebody else. Thank you very much for good listening.